Thank you for the opportunity to be here. I want to thank my friends at Info Exchange to make this happen. We're going to go into the why. That's the first question I want to answer. Why things are probably not ideal in IT. So the title of the first half of the presentation is Complicated or Unreliable IT is Over. In other words, this is the what is happening or the why we are facing so many challenges. And after that, we're going to take a break, and then we'll go into the how to solve the problems. If you all agree with me that the problems that I'm about to present are real, then we will talk about how we can possibly solve them. Now, today you're going to hear some things that they sound too good to be true in some cases. So please, feel free to say so. Feel free to challenge us by saying, that sounds like fiction, right? So we can explain better why this is real. The good news for all of you is whatever we are presenting today is real. It is not something new. It is being used by many, many organizations around the world, especially the biggest well-known companies around the world are using this technology now. So we invite you to join the wave. This is a big game changer. So let's get started. What is happening in IT nowadays? This first part, I don't want to get into technical details. Those are boring. And by the way, I want to share something interesting too. My background is, yes, I have been in virtualization and storage for 15 years. Yes, I've been implementing solutions. I've been lucky enough to be pretty much on every continent, implementing in so many different countries. I lost track now. But the most important part that I want to share with you about me is I came here as a customer. 4 or 5 years ago, I was sitting in one of those tables listening to the presentation, and when somebody presented this technology to me back in 2012, I said, this is what I want. So just like many of you, I was running a big data centers. I was in charge of the largest hotel hospitality company in the world today, Starwood Marriott. And I had the privilege to design their data centers in the United States. 3 data centers protecting each other, distributed architecture. Back then, the challenge was to create the virtual and storage infrastructure. I also had the privilege to listen to this pitch, understand the benefits, and take that company from traditional technology that I designed myself to hyper-convergence, which is what we are covering today. So I'm sharing this with you because if you have any questions around, again, from a customer perspective, why I loved it, why I believed in it, and why I put my job at risk by adopting something that back then was new, and it was a successful project. But if you want to know any of the challenges and how that migration happened, feel free to ask. Okay? So again, I'm here because I was a believer since the beginning. So back on track. IT. What's happening in IT? Who has the problem here of getting too much money or more about budgets? Are budgets growing? Is anybody here getting more money than they need? No? So IT budgets are, I put it as a flat line, right? Just if we are lucky enough. The reality could be decreasing, right? I mean, it may not even be a flat line. It may be getting less and less money. So we IT people, we don't have the luxury of getting more and more money to spend on the best toys, the best technology ever. If we are lucky enough, we get that, flat line. The problem is not only not having more money, the problem is what about the user expectations? Our end users, whether my customers are external or internal in the company. Do they expect the same or less, just like my budgets? They expect more, right? What about complexity? Complexity is growing. IT complexity, I'm getting more vendors, I'm getting more solutions, more products, more platforms, more tools, more and more and more licensing. It's getting very complicated. And if somebody doesn't agree, please, or if somebody wants to share an example of what I'm saying, by all means, jump in. So budgets are flat or less. Complexity is growing, so many vendors and new solutions. Expectations are even worse. My end user expectations are growing even further. They are just expecting more. What am I meaning here? They expect agility. They want to request something for, I don't know, a new application to be deployed. And they want it now. They want it tomorrow. or today. Speed, they want it right away. They want all applications to perform super fast. Everyone wants a nice experience. So I'm IT. I have hundreds of users expecting a lot more. I'm not getting any more budget. I have very complex environment. I'm not getting more people either. My team is not growing typically, right? I'm not allowed to hire more people than I need or than I have. So again, how do I fill this gap? How do we solve more complexity, higher expectations with less budgets and less people? Does anybody not agree with this chart? I think this is a good way to represent what's happening in the IT world today. Any comments here? No? Good. So typically, my question is, how do I fix this? How do I fill that gap between expectations, budgets, and so on? I'm the IT director, or I'm the CIO, or the CTO. How do I solve this with the resources that I have? Do I send my people to more training? Do I replace everything I have? I throw it away and buy something new? How do I solve this? On top of this, I can probably answer better if I say how to not solve it. I don't know yet how I'm going to solve it, but I do know how I will never solve it. The way I will never solve it is by doing things the same way I've been doing them for the last, I don't know how many years. So our traditional data centers that we've had for the last 20 years or so, they look like this. That's exactly how we will never solve the problems. I mean, if I keep using the same technologies, everything we see here, this is a traditional data center from the 90s that many of us still do have and operate today. And maybe it's smaller or bigger, it doesn't matter. What matters about this technology is it's a group of different vendors, different solutions, somehow interacting with each other thanks to industry standards, yes, thanks to standard protocols. At the end of the day, we have so many different components, so many different solutions, so many different vendors. I have storage, I have compute, I have communications, I have between storage and compute, I have another layer. So many layers and solutions. So many licensing for each one of those components. So many tools to monitor and manage each one of those components. I mean, if we think about it, this has not really changed in a very, very long time. The architecture is exactly the same since the 80s and 90s. So how do I expect to have different results when I'm doing things exactly the same way as I was doing it 15 years ago? So this is the back of those racks. That's even worse, right? When we don't look at the front of the cabinets, when we go to the back, it looks even worse, right? So what I'm trying to say with these pictures is, and this is real, right? I mean, this is not fiction. I've seen data centers worse than that. So complexity, that's one keyword that I want to take with us today. Complexity is not helping us. Of course, costs and the way we purchase technology is also not good. Because with this, I'm going to go back to this slide. How do I purchase this technology? How do I know what I need? It's almost impossible to know exactly what I need. So what I end up doing, me as a CIO or CTO, I have to overspend to be safe. So when I have the opportunity to take a little bit of budget and spend it on technology, I just try to cover myself for the next 5 years or whatever the time is. So I'm overspending now to kind of be safe. Because when in a few years, some vendor is going to tell me, oh, you know what, I have the new model of this, and guess what? You need to buy everything new, get a new version of whatever, and migrate it all. And I don't know how many of you have gone through migrations, but migrations are not fun. They mean downtime. They mean business disruption, which is not a good thing. And they mean everybody points the fingers at IT. And people don't understand when I say, well, but I have to do a migration. My CEO doesn't care about migrations. He doesn't understand about this. My CEO doesn't know volumes, LUNs, SAN, servers. He doesn't care. He cares about business. He knows that a business intelligence dashboard showing the sales in real time against my competition. That's valuable to him. He doesn't care about this. Am I right? So how do I explain to my CEO or to my strategists that IT has to be down because of a migration or because of whatever I'm doing? They don't care. That's the reality. Again, expectations are very high. So one more time. This data center that means complexity, means overspending, means many different skill sets. We haven't even touched on skill sets yet. How many specialized skill sets do I need to operate those things? Typically, I need SAN experts, storage experts, right? Do you think there's an excess of SAN experts on the street? Is there a lot of talent out there who really know how to manage those systems? I use SAN as an example because it's a very complicated component of IT. There's not an excess, right? I see some people agreeing. It is not easy to manage a SAN. And I've been there myself for many years too. Those people who know how to manage the fiber channel switches and those complex components are not easy to find. If I have one in my team, I'm lucky. If I have two, well, you're blessed. All right? So specialized skill sets. And the guy who knows the SAN or the lady who knows the switch, maybe they went on vacation. What happens? I've been there myself with my family on the beach when somebody calls and says, I don't care what you're doing. You better get on the computer right now. I need you to VPN into the company and help me with a SAN issue. And you have to drop whatever you're doing and then go back to help the company. Specialized skill sets, complex IT. What else can we think about this model? Anyone can share anything? Any other disadvantage of this model with me? Or maybe something good about it. Because what's good about it is that it has been working. That's true. It has worked forever. But that doesn't mean we have to keep things going the same way they have. So again, if we expect different results, I believe we should do things differently. We can't expect to hit a ball a certain way, and that ball is going to go in a different direction. If I do it the same way, the ball is going to go the same way. It's that simple, right? So if we want IT to deliver different results, to perform in a different way, we have to do things in a different way. To make things even more fun and more complicated, we have technology disruptors. Why I'm using these examples? Because these companies have impacted our everyday life. I'm not talking about IT anymore. I'm talking about we as consumers, right? Companies like Apple and even, the invention of the car itself, they changed everybody's lives. Why I'm using these examples? Because when we as consumers get experiences like when the smartphone was invented. I remember when this guy released the iPad, a lot of people immediately said, who's going to want a giant iPhone? I remember that phrase. And it's one of the best sold devices ever in the world, right? I mean, the iPhone itself has millions and millions hundreds of millions of units sold. So we can spend hours here together arguing about why those devices were successful or not. But what is true, and I think everybody should agree, is they changed the game. Apple changed the game with the smartphone, creating the first real smartphone. The funny thing about these companies is many of them were not the first ones to create something successful. So the smartphone, Apple was not the creator of the smartphone, right? There were so many attempts before them. Why Apple, a company who had nothing to do with phones, created the best-selling phone in the planet? Why did they do it? Was it the phone itself? Was it the hardware? Was it the CPU? Those things are becoming more and more irrelevant now. It doesn't matter anymore if the phone I have in my pocket has X number of gigahertz. It doesn't even matter the memory or the model of the CPU. Those things are becoming more invisible every day. I love also that phrase from Henry Ford because it reminds me how people who are visionaries, they really understand what people want, even when people don't know yet what they want. I mean, I love that phrase. If I ask people what they want, they will ask me for faster horses. Well, that's all we have. We have horses. I want a faster horse, right? I didn't know I wanted a car. because somebody else had the vision to create a car. When that's what I needed, yes, humanity needed a car, but we didn't know. So just like somebody knew what we needed in terms of phones, in my humble opinion, the success of the iPhone was the App Store and the whole ecosystem around it, was not the phone. This guy had a vision far beyond the phone itself. Phone doesn't matter. The experience is what matters. When I get a phone and I push a button and that thing deploys an application with just one click, that's important. It's not important how many gigahertz it has. So drones, phones, cars. Today we have the Teslas. It's a great example, right? And I have it on my next slide. Not only technology disruptors, but many of these companies are also driven by software. That's another thing in common that I want us to remember today. Software-driven era. We are living a software-driven era. Think about it for a second. The biggest transportation company in the planet owns 0 hardware and 0 cars. Uber, right? How can you try to challenge transportation when you don't even own a car? I mean, it's a brilliant idea, but none of us had that idea here. I would be rich if I had that idea, right? Uber changed the game. They decided to just use software, create an application, and put it in the hands of everyone in the world, and use everybody else's car. How brilliant of a concept. Again, the iPhone as a platform, not as a device. Think about it as a platform. Think about Tesla. Does everybody know Tesla? What did Tesla do? What did they do right? Again, they didn't invent the electric car, just like Apple didn't invent the smartphone. What did Tesla do right? They invented the software-defined car. It's a totally different story. And their end game is not even the car. The car was the first step for them to get to where they really want to go. They are all about energy. They are selling solar panels, solar tiles. Their end game is different. Just like Apple had a different goal in mind, Tesla has a different goal in mind. But they have to start with the cars. They have to start somewhere. So again, Tesla is a software-driven car. I don't know if you all know, since you are aware of Tesla. Did you know that this car got faster and more powerful via software update? Imagine that. You buy a car. A year later, somebody sends you an email saying, hey, that car that you bought with 200 horsepower, whatever the number is, now it has 250. Without changing the engine. That was impossible to dream. Now, think about that in IT terms, in our IT world. Imagine that storage device you bought 5 years ago with 100 terabytes. Now you get an email and somebody says, oh, now you have 150 terabytes. I didn't touch it. You didn't touch it. You didn't buy anything else. I just added you or gave you 50 terabytes for free. How is that possible without touching it? So whether it's a car that gets faster thanks to a software update, whether it's a storage device that gets more capacity, or your IT data center can get more efficient or get higher performance thanks to a software update, we are living in a software-driven, software-defined era. So that's another key concept that I would like you to take with you today, software-defined. And we can apply that to networking. We can apply that to servers. We can apply that to, again, consumer gadgets, transportation. Networking is very common today to talk about software-defined networking, right? Microsegmentation. There's a lot of people talking about software-defined networking. The reality is when we move the intelligence to software as opposed to hardware, things change. Things become more agile. We can now be more flexible because software can be updated over the air. I can get a software update and solve a problem. Also, with this era of security issues, we are getting attacked from everywhere, right? So what can be better than software to protect us, since a software update can solve a vulnerability, can resolve a security hole. So to make things even funnier or more fun, cloud came to complicate everything. Cloud is a Very nice concept. The funny thing about it is, if I ask each one of you in this room your definition of cloud, chances are I'm going to get 50 different answers. It's very hard for two people to agree 100% of what cloud is. So cloud is an interesting concept. We are talking about cloud every day. Do we agree on what it is? Doesn't really matter. We all have a good idea of what it is. What matters and what I think we all agree on is the potential benefits of the cloud. But cloud, again, came to complicate everything. Because now we all are like, oh, I like that concept. Sounds good. We haven't even agreed on what the cloud is. I can give you my definition, and I have a very short and very simple one. You probably won't like it, but I will share it with you. To me, the cloud, in a very simple way that I can explain to my daughter, the cloud is somebody else's computer. That's my definition of the cloud. And many years ago, we would have said, why in the world would I use somebody else's computer? That doesn't make sense. I don't even do it at home. I don't use my wife's computer. Her computer is hers, and don't touch mine, I don't touch yours, and we're all happy. So if I don't do it at home, why am I going to do it somewhere else? Why am I going to put my IT in the hands of somebody else's computer? Well, guess what? That's happening nowadays. But it has something very important on top of that, somebody else's computer. What is it? What is on top of that? Software. Software defined. You put a layer of software on top of it, thank you, to make it intelligent and to make it easy for me to use and to consume. Many organizations say, there's no way I'm going to put my data in the hands of somebody else. Or some people want to, but they have a government regulating that, saying, no way, you can't do that. So whether it's a regulation around the privacy of the data, or whether it's I just don't trust it, privacy of data is the number one challenge against the cloud. There's also the problem of depending on internet links, right? Connections, are they reliable to the point where I can depend 100% of that? Sometimes I don't trust network connections. So if I don't trust the internet, well, why am I going to use the cloud if I depend on the internet? So that's another potential reason to say no to the cloud. The cloud they told us that it was going to be cheaper, right? Didn't they say that? Oh, come to the cloud. Everything is going to be cheaper and you will be happy forever. My question to you is it true? Is it really cheaper? Has anybody tried and gone to the cloud? And has anybody come back, by the way? 60% of companies in the planet that go to the cloud come back within a year. 60%. And again, this presentation is not against the cloud. I love the cloud, and we are all about cloud, by the way. But we need to be honest. And before being Nutanix and before being anything, I am a consultant, and I have my duties to be honest to myself and to my audience. So the cloud is wonderful in concept, but whether it's data ownership, whether it's cost, whether the reason is one of those, at the end of the day, the benefits that I have here on the screen are real. The cloud sounds great in concept. They told us it was going to be rapid, right? Rapid to deploy. How long does it take to deploy a data center nowadays? Let's say I give you a new room, new data center, and I bring all the boxes, switches, servers, SAN, everything in boxes. Can anybody give me an estimate how long it's going to take me to deploy from boxes to production? If you tell me days, I'm surprised. This is the first time that I hear that answer. Typically people agree that it's months. I mean, some people say 3 months, 6 months. It doesn't matter, but it could be months. But anyway, let's agree on weeks. I'm gonna settle in the middle, right? Let's settle there on weeks. Compare that to the cloud principle. The cloud says, click here and you have a machine working. Whether you want a server or 100 servers, it's just the same. You just click. Now, I have to ask you something. Do I care what is below that virtual machine that I just deployed? Do I know? Do I know the hardware, the brand? Do I know the hypervisor that they are running on? I don't care. The reality is it became invisible. The cloud gave us a very good lesson about invisible infrastructure. They created the concept of invisible. They said, Don't worry about the hypervisor. Don't worry about the server that I'm using. I don't know the brand. Worry about the results. Just like Apple said, worry about the end user experience, or like Tesla said the same thing. That's what we are discussing today. Worry about the end results. Get your application deployed, running, and forget about the rest, because the rest, it just works. Just like one of the videos said. It just works. And you don't have to worry about gigahertz or anything about that. So rapid time is one of the things that cloud vendors brought us. Beautiful. Fractional consumption. That's another one that's very appealing. Fractional consumption means pay for what you need. Pay as you grow. Beautiful. Now I don't have to over-purchase anymore. I don't have to purchase for the next 5 years. Well, how about if I just pay for what I really use? If I have 100 servers, I just pay for that. If I need 50 more, I just add more capacity. It's as simple as clicking a button. So it's beautiful. Nothing can be better than that from a purchasing perspective. I don't have to overspend. I make my finance people happy, and I am happy as well. Continuous innovation, well, this is probably one of the least important reasons to move to the cloud, but it is true. The cloud providers are continuously innovating. They are giving me new features all the time. They are adding functionality, making things better for me. And does that impact my workloads? No, my servers are running. They are improving their platform. They just send me an email saying, hey, yeah, now you have 10 new features to enjoy. Thank you. As long as my applications are running, that's all I care about. Just like the car that got faster, the cloud gets better and more efficient, and I just get notifications. Sounds great. And number 4, one-click simplicity. I kind of covered that already, right? I click a button, things get deployed. I click another button, things grow. I need more storage, I click a button. So the one-click simplicity is something that not even in my dreams I can have today in my data center. But hopefully in the cloud, that is true. So the cloud sounds great in theory, but I don't have it at home. And the price to pay to go there is very high. What is the price? Take your applications and your data to the cloud if you want to enjoy those things. So going back to your question, Andrea, how do I get those 4 benefits and more, many more, without paying the price of going to the cloud? That's what we are going to try to answer today. Get those benefits, get the flexibility, eliminate the complexity, make my infrastructure invisible, get exactly the same behavior as the cloud, but bring it home. Bring me the cloud home. That's what I'm trying to tell you today. How do I bring the cloud home? If I tell Amazon to come to my house, they're never going to do it, right? Or Google. By the way, I told you the concept of the cloud started at Google. They were the true creators of this. Google started with building their cloud for Gmail and other things they did, but they realized there was no way to achieve this dream with traditional technology, like the one I showed you on the screen with the old data center. There's no way to build a Google like that. There's no way to build an Amazon like that. So what they had to do is to create a model called the Google Distributed File System. It's a very simple concept, by the way, powerful but simple. Just make a totally distributed system where everybody, every box, every component is the same. They all do the same. It's like a Lego game. We are going to talk about Legos in a moment. But think about Legos where I just add more pieces to my Lego, right? So benefits of the cloud are real. We know that. But we also want to know how to enjoy them at home, because we all agree, I believe, that the cloud is not for everybody and not for everything. So to make things even worse, I'll have this joke to share here. To make things more complicated, it's not only one cloud anymore. Since the cloud became so popular, we started talking about different types of clouds. Private cloud, public cloud, hybrid cloud, distributed cloud. It's getting more and more fun, right? So this joke here is around the hybrid cloud. What is the hybrid cloud? Again, everybody may have a different answer or different theory about it. I'm not going to get into the why hybrid cloud is or not something, but the reality is there's different types or variations of that technology today. So the hybrid cloud is a reality. We have public clouds, the main players, AWS, Amazon, Google, and Azure, the three big players that we all know about, with the benefits that we just mentioned. We also have the private cloud. I call the private cloud what I have at home today, right? It's not a real cloud, but that's what I have home in my data center. I have this, I have the public cloud, and maybe if I am a big organization, I also need distributed clouds or endpoints. That's a typical case at the hotel industry. We hotels needed central data centers, but we need a little bit of infrastructure at each one of the resorts or stores or theme parks that we operate. Am I right? Each one of those hotels must have enough infrastructure locally to operate independently of any outage. If the connections are broken, that hotel must be able to process reservations and a little bit of the everyday transactions, right? So that's what I call the distributed cloud. Whether it's a hotel, whether it's a ship, whether it's a cruise ship. Cruise ships are floating hotels. They have casinos, they have stores, they have a lot of transactions going on. They need infrastructure locally. Are they going to rely on satellite communications? That's all they have when they are in the water, right? They can't rely on that. They have to have a little bit of a local infrastructure, whether, again, it's hotel, ship, airplanes. Airplanes have local infrastructure. Airplane computers make about 700 decisions per minute in average, just to keep those things safe. So there's infrastructure on those devices. Oil rigs, anything you can think of. Many companies need distributed infrastructure. I call it distributed cloud in this case. So public, private, and distributed. How do I connect all those dots if I want to use them all? Because maybe there's still a case for me to put something in the public cloud. How about if I put my dev environment on the public cloud? It makes sense. Connections go down. Well, it's dev, right? Maybe I don't care too much. Maybe I want to keep production, my ERP, in-house in the main data center. I mean, putting an ERP in the cloud may not be the best idea for me. But maybe I can have a copy of that environment and put it in the public cloud. Why not? And not consuming internal resources. Edward knows about the ERP challenges, right? So how do I make all these three connect to each other? Imagine a world where you have applications, you have virtual machines, and you let the software-defined layer or the software decide where to put them. We, IT leaders, we make the important decisions. One important decision could be, I want my ERP right there at home all the time. That's a rule. That's a business rule. IT should be around business rules, not the other way around. I cannot tell the business how to behave just because I am IT. I'm not supposed to dictate how the business runs. It's the other way around. IT should be a business or a service provider to the business, if that makes sense. What I tell a lot of my friends, CIOs and strategists, is why don't you become the Amazon of your own company? Why don't you become that service provider in your own little world? I don't care how big or small your company is. You could be a 100-people company or a 10,000 people company. Why don't you become that internal service provider? Why don't you tell the CEO that now you are an Amazon inside providing services to all the rest of the company? Whether you want to charge internally or not, that's a different story. What I'm saying is, instead of being a necessary evil, some companies still see IT as a necessary evil, right? Oh, the CEO says, I have to spend how much on computers? And we IT people, we are like, oh, don't say that. We are not only necessary. Without us, you can't exist, right? We are not a necessary evil. We are what allows your business to run. So why not changing that mindset from a necessary computer that the CEO must buy to a service provider inside the company? Why don't you let me become an Amazon inside our little world, and let me invest in technology that can allow all that to coexist together, to talk together. And again, imagine a world where applications can float freely between public, private, distributed, replicate each other, protect each other, exist everywhere. So if this one on the left is not available, I mean, even public clouds are not available sometimes, right? When they are not, well, I have everything on-prem replicated. I can really, in real time, migrate or move based on business rules. Again, business rules are more important than anything, more important than technology. I just dictate the business rules, and I let the software enforce those rules. I can tell my technology, my platform, I can tell it, I want distributed workloads everywhere in every point, but I want them replicated to the main data center every hour. That's a business rule. And I want the ERP to never move from the private cloud, from the enterprise, from the data center, but I want it protected everywhere else, every minute, real time, or whatever I decide, in case of a disaster. So it's going to run there. That's my business rule, except for a disaster situation. At that point, I want to click a button and run the ERP from every distributed location that I have. That's a business rule. But IT, the traditional IT has not allowed me to do this. Let's say I give you the magic wand and you are Amazon in your own company tomorrow. What would you have? If that's true, if I really made you the Amazon, you would have what in your power? What do you think you would have in that moment to make that dream come true? You would have what?
I mean, what I would like to have.
Yes. It's a fiction. It's fiction right now.
Well, I would like to have something that I can deliver services seamlessly.
You would deliver services seamlessly. So basically, a one-click service delivery. Right. That would be your dream. What else?
I just like to be invisible, really.
Invisible?
Yeah.
Okay.
Yeah.
Not you, right?
No. Yeah. It's similar to what my colleague here has said, but we, just like Amazon, we really don't see it. We just know the service, and that's what I would want for my company. I work in healthcare at a hospital, and so many of these challenges are very, very real.
I would like to ask you all to remember these concepts because these are important to answer during the rest of the presentation. You said seamless application delivery. You said make my infrastructure invisible, just like we talked about before, right? Make everything invisible, but make it just work, right? I want it to work. So invisible, it just works. Seamless delivery. Simplicity. Thank you. So make it simple. Let's make it simple. I don't want the complexity of traditional technology. Anybody else? Any part of this dream? We are building a dream together here today. That's what we are doing. I don't know if it exists or not, but, well, we know, right? But, but we are building our dream, and I want to make sure that every part of that dream is solved today with the rest of the presentation. Yes? So make my applications that I delivered seamlessly and I delivered in an invisible way, make them available 24/7. Is that what I'm hearing? Without sacrificing my team's life, because sometimes making available means my engineers are nights and weekends in the data center. Does that sound familiar to any of you? Spending nights in the data centers or weekends? Is that fair? I mean, we all want a life, right? I prefer to spend vacation when my family is having real vacation instead of just fixing patches or volumes or disks, right? So you mentioned availability, business continuity, in other words, seamless application delivery, invisible. Anybody else? Any other concepts that I want in this? Scalable. Thank you. That's a beauty one. That's a beautiful one. Scalability. So I want this dream, I want this new platform that I'm building, or this dream that we are all putting together, to be scalable. Scalable meaning, let's just be clear for the rest of the group, grow without restrictions. Does that make sense? Do you agree on that? Everybody else? How if I can grow a platform without any single restrictions? That doesn't exist today. Do you agree? I mean, everybody says, oh, this is scalable. That's not true. That's marketing. That's marketing. The reality is 3 years later, that vendor knocks my door, which, by the way, I haven't seen that vendor in 3 years, but they knock that door to say, guess what? Version 2 of the beautiful scalable product you bought is now available. And I have my engineers here to spend a month with you to migrate you to version 2, right? So I want to charge you for services, I want to charge you for consulting, and I want to charge you for the new box, which is going to solve all your problems for another 3 years. Anything else? We are building the dream together. Reliable. So what would that mean to you? Reliability means available, like we said, or means fast, speed, or what do you think? Ability to recover from failures. So can I describe that as a self-healing platform?
recoverable from internal issues or capacity problems, that should all be transparent to the user. So if I have an issue with a failure of a component, they shouldn't even know that in the first place. It should all be transparently handled seamlessly. So very reliable, high integrity.
So Brian says, okay, my part of a dream is I want this platform to be self-healing, to recover itself from any kind of failure. And I don't want, it should be resilient, and I don't want anyone to know about it. What if my business changes? We in hospitality, I'm exceeding my time as usual. That happens to me all the time, don't worry. In the hotel industry, we know this. We buy companies all the time, right? We buy hotels. I mean, who would have thought that Marriott would buy Starwood? I mean, those two giants, Marriott just decided to buy one of them. When that happens, IT suffers, right? Because somebody comes to my office and says, guess what? We just bought a new company, and you have X number of days to deliver this capacity and this agility for the new company. Are we ready? And you have to merge everything, and you have to make everybody happy with that acquisition. And we IT, we know it's not that easy. We are challenged with those acquisitions and those business expansions. But the reality is we are not ready. We IT are not ready. The business is ready to buy. They make those decisions without asking us, right? Without us asking. How many times do they consult IT before they purchase a company? Never. They don't care. They say, well, IT, you figure it out. You're IT, right? You do the magic. You have your magic wand. They don't ask us. Huh? Just make it work. Make it happen, right? I hate that phrase. Make it happen. I'm like, how do you expect it to make it happen? Yeah, give me the money at least. I'll make it happen, right? Oh, by the way, you don't have any extra funds. Just make it happen with whatever you have, or maybe less, right? So we acquire companies. We grow unexpectedly. We are expected to deliver results. That goes along the lines of agility. If I really want to be agile, I should be able to react to those situations with a good platform that is behaving like that. But I don't have it today. All right, I'm loving this. I like the idea of building a dream together. Thank you. What else?
What about optimizing costs?
And make it cost efficient. Now we are getting too ambitious here. This is becoming more challenging now.
I think everybody has that question in their mind when they came here this morning.
Okay.
That's going to be the bottom line. So how do you continuously operate within tune-in cost benefit to the service that you want to deliver? So not spending too much, just spending enough. How do you, and hopefully reducing costs as you go on?
So this dream that we are building all together here must also be cost effective, right? So because it would be nice if we build something, but if it's going to cost $10 million, well, maybe I may not be able to afford it, so it's useless at that point, right? So I like that. Thank you. Anything else? No? So cost effective, yes.
Yes, I want high performance.
Oh my God. Now I think we are asking for too much now. Are you helping me with the notes, David? Thank you, because these are great comments. All right. And he also has to be a high performing. In other words, has to perform better than what I had. It has to be invisible, has to perform better, it has to be agile, has to be elastic. It has to look and behave like the cloud. It has to be cost effective. It has to deliver application seamlessly, with maybe a self-service portal. It has to be reliable, you said. Thank you. Predictive. Okay, that's an interesting one. So is it fair to say that you would like to have some artificial intelligence built into it so it knows what's going to happen ahead of time? So add some analytics, add artificial intelligence, let the platform learn from itself so it can tell you, hey, this seems to be going in this direction. Do something before this happens. You want some predictive analysis, in other words. That's an interesting one, predictive analysis. That's a good one. Thank you. Yeah, some monitoring tools and management tools have a little bit of that, yes. You have to deploy those platforms separately, typically, yes, but some of them are better than others. Typically, monitoring platforms have a little bit of that. You have to purchase one, and you have to, in order to make the most of it, you have to get consultants to fully deploy and configure those platforms and tune it continuously, because those platforms, they learn from what they are monitoring, but as infrastructure grows, they don't know about that growth. So you have to, let's say you grow your private cloud with 100 servers. That application is typically not aware of that. So you have to feed those 100 servers into it so it knows how to start monitoring. But yes, management systems, sometimes they do a little bit of that to an extent, which means that's another layer of complexity that I haven't even illustrated here, the monitoring and the management, right?
I know operations manager and vRealize inside.
Okay.
Monitors the resources of the
Correct.
VMs.
Yes.
Migrates if the resources becomes low depending on the threshold that you set. So, what?
No, and you're right. I think
I'm just talking from experience that I know of solutions that does that.
true. And you're right. I mean, many tools, which are, again, a separate layer that you have to maintain and configure and manage and pay for, those tools do that. They are designed like, you mentioned a name. vRealize Operations Manager. All right, VROps. So VROps is a good example, a good attempt at that. The only problem that I see with some of those, including VROps, is that it doesn't have the predictive. It doesn't go ahead of time typically. They are reactive, like you said, based on certain thresholds. So it can make decisions around, hey, if I reach this level, please do something. So they are a nice, very nice attempt at being a little bit proactive. Some of them are better than others. But yes, you're right. There's that software layer that can do that for me if I include it in my platform. Good point. Thank you. My cloud should be able to expand. I don't think anybody asked me that part. Should be able to expand to secondary DR sites because I must, especially being in an island, I must be highly available as much as possible. So having those distributed points where my cloud can extend, where my applications can move dynamically, gives me an extra layer of peace of mind, right? So some of the things that we have learned during this first hour and so is we are using old and dated technology. So again, if you don't agree with any of these points, please let me know, and we can scratch it. I don't have any problem. I prefer when we all contribute to the summaries. We can't expect different results. We can't expect our dream that we are building together here. We can't expect that dream to come true if we use the same technology. That's for sure. Google realized that back in 2007. Amazon realized that, and that's why they had to say, well, I need to create something new because traditional technology will not let me grow. And believe me, even if it's Google and you think, well, I'm not Google, I'm not that monster, it doesn't matter. We all suffer from the same problems. It's just a different size, IT data center, but we suffer from the same. Whether it's Google or my hotel or your hospital, it doesn't matter. So we can expect different results with the same technology. The traditional data center that we most likely have today hasn't changed since the 90s. And probably 80s, some of those technologies that every one of us use here, like RAID, for example, it's from 1984, and we are still using it. So it's probably time for a change. Traditional technology is also very expensive. I have to purchase a lot up front. I have to over-provision, purchase more than what I need, and then try to be safe for the next years because I don't really know what is going to happen. And my traditional infrastructure is not flexible enough to allow me to pay as I grow like the cloud. Software-defined is a new era. That's definitely a given. We are in a software-driven world today, so I would like my data center to be software-driven. Software-defined data center is the correct term that I would like to be part of this new dream. So cloud changed everything, and it changed the way we think, and we would like everything to be like the cloud, but with the benefits of being on-prem. We also covered that. That's part of our dream. And of course, my last line here is that there must be a better way to do things.